standards and draft standards open for public commenting are also available. Proposals can also be submitted through the portal to make new Indian standards. Details about the technical committees, members, and their affiliations through Manak Online are just one click away.
Is this question time, sir?
Sir, the program is about to start.
ಇಲ್ಲ ಅಂದ್ರೆ ಅವ್ರು ಕೊಡ್ತಾರೆ ಅದು ಎಷ್ಟು
Because we keep doing here. Yes, sir. I'll tell you.
अरे यार कितना मैं सबसे ज्यादा कर रहा हूँ। हाँ great value. We go to some foreign and we will also do subjects. Only people will know. We able to understand. So inspire them. But when COVID came, we are not sad. Affected with water blooms and YouTube. I will give it this. I'll say WhatsApp from the world. This is what's the thing. तो वही इस हाथी के पैर में पैर देखा तो वही देखा है देखा ही मैंने जो देखा है अब मास्टर सही फाइनेंशियल लोग पॉलिटिशियन लोग और एनजीओ के नाम पे बकवास करने वाले फर्नीचर आधारित है क्या इन्होंने बात बनाया मिट्टी बचाओ
I think the program has started. Sound we are not able to hear.
Good morning to one. I'm Sandesh. I'll be your host today. A warm welcome for everyone on national seminar on urban flooding organized by Bureau of Indian Standards with Water Resource Department, Government of Karnataka, and Water Institute, UV Department of Civil Engineering, UVC Bangalore. Welcome to all the delegates, engineers, government employees, and all the online participants. A warm welcome to everyone. I would like to invite Sri Banu Prakash sir, Scientist E, Director and Head, BIS, to address the keynote. Sir, Sri R. Banu Prakash, Director and Head of Water Resource Department, Bureau of Indian Standards, New Delhi, India, is a civil engineer and has done his bachelor's in civil engineering from PES College Engineering, Mandya, Mysore University. He did his MTech in industrial structures from Mysore University, Karnataka. Sri R. Banu Prakash has more than 34 years of experience in various fields of civil engineering. Now, I'd like to request Sri R. Banu Prakash sir to give the keynote address.
Good morning, all. So, respected speakers are Mr. Dr. Subbarao, then Yogesh Chandra Agarwal, then other speakers, those who are on online and offline, and the distinguished engineers from the irrigation department and civic bodies people and all my friends and colleagues. I am very honored to stand before you to welcome to this crucial seminar on urban flooding. On behalf of Bureau of Indian Standards and Water Resources Department, I welcome all of you for this gathering. This gathering brings together a diverse group of experts, professionals, and concerned citizens, all united by a common goal to address one of the most pressing challenges facing our cities today. Urban flooding is a complex issue that touches the lives of millions, impacting communities, economies, and the environment. As we know, the frequency and intensity of these events have been on the rise globally, necessitating a concentrated effort to understand, mitigate, and adopt the changing dynamics. This seminar provides a platform for the exchange of knowledge, experiences, innovative solutions shared by our experts. It offers us the opportunity to learn from each other, to challenge the existing paradigms and forge new path forward. Together, we can develop strategies that not only respond effectively to immediate crisis, but also build resilient, sustainable cities for generations to come. On behalf of WRD, Vaibhav Yadav will be speaking about our programs on this SNAP programs 2022-27. And he will be briefing about the actions plans what we have taken on this particular subject. As of now, there are no standards in Indian standards or international standards. We have already made a committee, and this committee is working out for coming out with good standards on this and good practices. I extend my heartfelt gratitude to all the speakers, panelists, participants for dedicating your time and expertise to this cause. Your contributions are invaluable, and they will be undoubtedly shape the discourse of urban flooding in the meaningful ways. Let us approach this seminar with open minds, a spirit of collaboration, and shared commitment for creating a safer, more resilient urban environment. Together, we can make a significant impact in the fight against urban flooding. So I once again welcome you, all of you, to this seminar and participate. Thank you.
Thank you, Bhanu Prakash sir, for your wonderful address. Now I'd like to call upon Sri Vaibhav Yadav, Assistant Director WRD BIS, for an overview of standardization at WRD BIS.
Hello. Good morning, everyone. I welcome you all to the National Seminar on Urban Flooding. So, topic of my talk is basically to give an overview of the standardization activities at BIS. But first, I'd like to talk about general BIS and why we needed this seminar. So, BIS is the national standards body of India. Primarily, it has three main activities: certification, standardization, labs. Standardization being the primary activity. So, I attend a lot of programs such as this one. Seminar. Yesterday we had sensitization program. Sometimes we have guest lectures in educational institutions and other programs. So generally we run through the same presentation. We give an overview, what we do, how we do. But I've felt over a period of time that there are some questions in the audience's mind, some issues that keep cropping up again and again. So I would like to begin by addressing some of those. So one of the things that BIS does is certification. So certification, does anyone have any idea what certification is, what BIS does? Standardization. See, one of the misconceptions that I would like to talk about is that people think that BIS makes standards. It's a misconception. We actually don't make the standards. We provide a platform on which standards are made. So I keep encountering this question again and again. I would like to talk about it. We have in BIS sectional committees. So there are, firstly, let's division councils. At BIS, we have 16 division councils, 16 departments basically that make standards on various topics. You can see the division councils here. We have civil engineering, chemical, electrotechnical. Ours is WRD. I'm from Water Resources Department. We make standards on water resources. So,
can you maximize the slide, please?
Increase the size of the PPT. Can we zoom the PPT a little?
No, it shows the next slide also. Please use the presentation mode.
Is there problem? But I think online people are having some problem. No, that's not how it works.
If there is a technical issue, you can continue, sir. No problem.
No, it shows next slide and notes section also. If you use the presentation mode, it will show only the slide.
Hello. 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 Okay, I'll just proceed. So it's not going back. Can we have that slide again? Vikram, slide. Back. Okay, it's working. It's working now. So
Try
I'll see
pressing,
today's
try
answers.
pressing Shift F5. It will go into presentation mode.
They're not seeing it in presentation mode. Otherwise, they won't be saying it.
Now, shortcut Shift F5 will work.
Give me just a minute. Yeah, is it okay now?
Yes, yes.
We'll proceed. So, like I was saying, WRD is one of the division councils at BIS, and we make standards about water resources. So, the question that we keep getting is, why don't you make standards this way or that way? The people want changes in the standards. I would like to convey that we ourselves at BIS don't make standards. I've even had some discussions regarding where people have asked that BIS should do some more research work. I mean, we have a recent initiative where we are financing some R&D projects, small R&D projects, but we can't do fundamental research. That's not our imperative. What I would like to tell you is that BIS merely provides a platform on which standards are built. At WRD, as you'll see, these are the sectional committees that we have. We have 17 sectional committees. Each sectional committee has a composition. We have experts, subject matter experts from various organizations. We have regulatory bodies, we have government organizations, we have private organizations, we have labs, and we have NGOs, consumer organizations, and they all come together and they make a standard. We are a team of 6 officers at WRD in Delhi. So 6 people alone can't make a standard for the whole country. Can't be just us. We need your help, basically. You have to read the standard, understand them, give us comments. You have to help in that process. We can't do fundamental research and we can't make standards on our own. That's why we merely provide a platform and we don't make standards on our own. Next query that I keep getting every time is regarding the implementation of the standards. That's another area where we need to understand that we as BIS, as National Standards Body, every standard that we make is inherently voluntary. It's not directly enforceable or directly mandatory as such. Whatever standards that we create, they're voluntary in nature. So I keep getting questions that why is this standard not being implemented this way? That's precisely why these sort of seminars and programs and sensitization program like yesterday's, they're conducted. This is for awareness that these standards do exist and you should use them. And it's better for everyone if we use them. The people in policy making should emphasize on the use of standards. For example, if some project is being undertaken, Indian standards should be taken into cognizance while proceeding with the project, while preparing the DPR or estimates or construction. So that's another thing that's very important. State governments, central governments, and the policy makers need to emphasize on the standards, and then only they can be implemented. Even for product certification, you'll see our ISI mark, they become mandatory only after a ministry, the concerned ministry, gives a QCO, quality control order, regarding that product, that this product has to be mandatorily certified. Only then can we enforce it. So that's another question that I keep getting. So one more question that I keep getting is regarding the certification of products. People often at various programs keep asking me, sir, you guys certify, but I've seen a product which was not certified. Yeah, obviously there are rules, right? We are all supposed to wear helmets while driving a bike. Not everybody does. You're supposed to stop at a red light. Not everybody does. So we have our standards, they're being enforced, but if they aren't, you have to get to us. You have to tell that to us. You have to report it. You can complain about it, right? There's a saying in Delhi police, be our eyes and ears. So you have to, if you see that somewhere this product is supposed to be mandatory and it's not being certified properly, you can tell that to us. You can raise a flag. So these are the three major issues that I wanted to talk about. These are the questions that I keep getting time and again at every program that I attend. Has any one of you any question about these three that I talked about just now? Yes, sir.
Can I ask a question?
Thank you for asking for feedback and a question. It's not a question. I want to reflect, being a member of WRD 10, my experience is everything is in position, but something is missing. That is, these questions come again and again because we do not have a mission approach. A mission approach will have a project document, let us say mission document, which will have duties and responsibilities of the person concerned. Just to share, I was heading a training institute in 95, Danida Institute. We were only 3 people. We were approaching Pollution Control Board, government departments, NGOs and industries. We developed 15 training programs in 2 years. Only 3 of us. And we had 100 part-time trainers. I want to just share a model. There has to be a model in the organizational structure because the option we have is only 3. One, revenue mode. Revenue mode means if the person is indifferent, nothing moves. Project mode, there will be some fear. But in the mission mode, I don't want to explain it. ISRO is an example, where I served 3 decades. So please have these things addressed. Person should have duties and responsibilities. Person should have some end point, activity schedule, and responsibility. I think all the 3 questions should be preempted. This is my sincere feedback for your observation.
Okay. I would like to inform that the mission exists, and as you said that there should be trainings. The trainings are being conducted. In fact, just a few days ago, there was a training at NETS. I think you also attended program. So for us also, we get training from time to time.
Have a training in the international mode.
Yes,
Your approach is totally different.
yes, sir. Yes, sir.
In the organization,
Yes, sir.
there needs to be a continuous capacity building.
Yes, sir. That's
Otherwise, it will become a revenue mode. Revenue mode means if a person doesn't come,
yes, sir.
things don't move.
Yes, sir.
Please.
And
So,
another question.
yes, sir.
Vaibhav, what is here now? Many standards are missing because it has to be modified, and now reuse of water for all purposes. Now just we are using in parking and all, but now the construction industry, they want to use this reuse water. For that we need a particular standardizations.
Yes, sir.
And here, many organizations and research organizations has done lot of work. And we already prepared a manuals also for that what should be the standards. And those standards and those guidelines are missing. Even KC Valley in Bangalore, what we are doing is we are treating and we are supplying water to Kolar and all, to all the irrigation tanks and all. Again, there also we are missing some standards.
Yes, sir. You're
So
very-
for all these things, what we are, that is we required, the purpose of this program also,
yes,
we should need, you have to conduct, keep on some training programs, workshop like training type,
yes, sir.
and get all the results from the people who are working in the field.
Yes, sir.
And it has to be finally summarized, and it has to come with a new codes,
Yes, sir.
new modification, new standards.
Yes, sir.
So lot of standardizations are required. That is very important. And already we are having lot of observed and the missing, what we are missing, those standards, manuals we are prepared already. But for that, certification or how BIS is going to utilize, or BIS is going to come up with a new standards. That is more important, which is very required.
As rightly pointed out by Vaibhav, it's a platform. Expecting them to conduct trainings is too much. Their job is facilitation. For example, you mentioned rightly, now all of us have been asked to submit a proposal for 10 lakhs, where it involves all this research, all this consensus building, all this documenting the existing practices globally and locally, and come out with draft proposal to BIS. See what happens, asking BIS to do all these things, will be asking for too much. Academic institutes are there, research institutes are there. We have ISC, we have got 70 plus engineering colleges. Our AMC professor is here, very actively involved in the field application. It is from there. I think I fully agree with sir with a modification, because asking for BIS to do this will be asking for too much.
Okay, sir.
Can I ask a question?
For circuit economy, like we should know, like for example, treated wastewater. Are we going to adopt 2020 standards or 1010 standards? So that itself is missing out in our BIS, right? And I think these incorporations are required. And when you talk about zero discharge, whether it's zero discharge should have 1010 standards. So that is very much important. And this has come into picture last year with the Central Pollution Control Board mandating 1010 standards,
See,
but not BIS.
I would, sir,
Yes.
I would,
NGT has gone to the extent of reviewing these standards, the SS and the BODs, which was conventional and age-old.
sir,
Now they are looking at critically, then we have to refer to BIS for their hand of stamping.
Correct.
See, asking them to do everything and it's not correct, please.
sir, hold on. Sir,
They cannot do the research work, they
No, they
cannot.
have to mandate. That's what we are telling.
sir, this brings me to a fourth topic, that I keep encountering again and again. A discussion begins.
Before
that
before you
some
move on,
standard doesn't
excuse me.
exist.
Excuse me. Before you move on, can you address the other questions I had?
Nagesh, 1
Yes, sir.
minute, Nagesh, please.
Just a second, sir. So, see, that's what I'm informing you. This is not the platform where I can discuss that what standards are missing, what standards need to be revised. See, BIS is a platform. It gives each and everybody in the whole country an opportunity to give their comments. You can say that this standard doesn't exist and it should. This standard exists, it's outdated, needs to be updated, needs to be revised. This standard exists, is totally obsolete according to today's new practices, needs to be withdrawn. You can write that to us, but we can't have that discussion here. It's a platform.
So, but see,
Okay.
that's part of the Constitution. In Constitution, we have the.
Sir, no, we're losing track of the program. I had 3 to 4 major issues that I wanted to talk about that I keep encountering again and again. Whatever queries you have, we can talk about them later. This is the national seminar for urban flooding. So I have to bring the program towards that. Okay. If you have any pertinent question, very focused question that you have a query about it, then you can ask it. But we can't have a lengthy discussion about general ideas. Okay. If anyone online.
May I add one point
Yes, sir.
here? See, for example, when you are talking about we are not the organization to certify or make up policy. Better what you can do is, out of all these section, this whatever WRD teams you have, you identify respective research organization in India who have exclusively doing, not necessarily the institute who are research, maybe the academy.
We have.
So then you make a draft copy of your whatever BA standards or whatever, send it to those committees or the identified institutions, ask them to give the broader and the focused comments on it, and then rectify or modify whatever it is. But so happens, say, for example, I'm sitting in Belgaum, National Institute of Hydrology. I am not in a position to access many of the documents from the BIS.
No,
but
sir.
my head office at Roorkee, probably they are the members of many committees, probably, I don't know. So it's better to give the access to such people who can read, give comments, rather than asking comments from a larger session.
Okay.
Session like this,
I can,
where you will get thousands of questions and all of the program will get in the other direction.
I can explain the standard development process to you. Yes, sir. Okay.
No. Even we are also technical members there.
That is the case. Why are we discussing here then?
He's having doubts.
So then he should not have the doubts because they are doing it in the.
No, they are not having doubts, sir. Please, he is asking the queries. That's all. No.
Hello?
No. Don't say. Say it, sir. On the points that will take, sir. We will be discussing at the end of the program.
Yes, sir.
Committees, we have experts, we do.
We do send it for wide circulation and all those things. The process will be explained now by
Okay.
Mr. Yadav.
So-
Yadav, please continue. Yeah, please continue. Please continue. Yeah, please continue, Yadav.
The process that you are looking at on the PPT, that explains how a standard is made. Exactly what you said, sir, that's exactly what's being followed. So a new work item comes to us. Let's say you give a proposal for a standard doesn't exist. We need a standard on a topic. That becomes our new work item. The committee then prepares a first draft. That first draft is circulated among the members, all the members, and they give comments on it. After all the comments are regularized, it becomes a P draft, preliminary draft. Then it's circulated again for comments. Comments are received, meetings are held. Then it becomes a WC draft. WC draft is wide circulation draft. This draft is circulated to everybody and it's open for everybody. Everybody can download it, read it, give their comments. Once we've received all the comments, we take them to the section committee. The section committee regularizes all the comments. Then after that, it becomes a F draft, final draft, which is then adopted by the Division Council, Water Resources Division Council. Then it becomes a national standard. That's the process. So at every stage, you have the ability to comment. Now, I would like to come back to urban flooding. We're gathered here for national seminar on urban flooding. So urban flooding, one of the issues about urban flooding, which again I keep encountering every now and then, is that there's a misconception among people that I've noticed is that they can't differentiate urban flooding from rural flooding. Sometimes even this time we were in Delhi and I had a discussion with my colleagues that there was the level of Yamuna rose quite significantly and there were alerts. I live near Yamuna Bank only. So we were discussing whether if a flood comes, that flood, should it be called rural flood, like a normal flood, or urban flood? Like what's different about urban flooding? Why the word urban? See, every flood that comes in a city can't be urban flooding. So what's the difference? Earlier, let's say 100, 200 years back, if a flood came, it's just a flood. Now it's urban flood. What's the difference? The difference is the causes of urban flooding. What causes the flood? See, when in rural floods, the flood is generally because of higher precipitation. There's a lot of rain and the river banks are overflown. And you have flood. Urban flooding is primarily due to poor drainage, poor planning, poor urban planning, and poor infrastructure in general, which causes urban flooding. So as you can see, unlike rural floods, urban flooding is not only caused by just higher precipitation, but also unplanned urbanization. See, we're covering, as we urbanize the landscape, we're basically covering it with concrete and bitumen. So we're not letting the water seep in. So, which raises the runoff coefficient. So earlier, when the water should have been absorbed in the soil, now it's running off into the drains and into the stream. And sometimes the drains are not properly planned. They're not well maintained, which causes urban flooding. So that's the key difference. Because of this, the increase in flood peak is from 1.8 to 8 times and increases the flood volume up to 6 times. So that's the key difference. Then we have to understand that this is a problem that we've created. Significance of the issue, urban flooding is a pressing concern, as we all can relate. Bengaluru is rather susceptible. I myself come from Gurgaon. Every year almost, there's some part of Gurgaon that experiences some form of urban flooding. So it's a matter that's very close to our homes, figuratively and literally. Consequences, we all are aware about it. There's economic loss, health and safety risk. It creates unsanitary conditions. Dengue fever is a major concern. Environmental impact, infrastructure damage. Causes that we can talk about for urban flooding. Primarily heavy rainfall, but that's usually the case. But even if there isn't heavy rainfall, even light showers can cause urban flooding. if the infrastructure is not properly established. Poor urban planning, inadequate drainage system, and sometimes the drainage system, if adequate, isn't maintained, isn't kept together. Then climate change, which is causing heavy rains. Issues in urban flooding. So we can see that encroachment is a major problem. So even in Delhi, we can see that we are building ever closer to the Yamuna bank. We keep encroaching the floodplain of the rivers. If our runoff is increasing, we should have wider floodplains. We should allow more area, but we're doing exactly the opposite. So this again is a problem of urban planning. Urban flood risk in India. This needs no introduction. As you can see, Hyderabad in 2000, Ahmedabad in 2001, Delhi 2, 3, Chennai 2004, Jamshedpur 2008, Delhi 2009, and so on and so on. So all over India, we have the problem of urban flooding. Way forward. So as we just identified the problems, so the solutions are similar. If there's poor urban planning, we need better urban planning. We need better drainage system. We need better maintenance of those drainage systems. We need identification of flood-prone areas. We need data and analysis. For that, standardization can help. If we have standards about urban planning, that how we go about it in a sustainable way that doesn't lead to unnecessary disasters. So that can go a long way to preventing such hazards. And standardization is a big step in that direction. So our WRD, Water Resources Department at BIS, has recently constituted a new section committee, especially for urban flooding. So we need to make standards. We need to make standards for the hydrological survey of the catchment, for analysis of the data, and how that data can be used for better planning of the drainage systems, for urban planning, and so on. So I again request all of you to kindly contribute. There needs to be a sense of stake and ownership. You can feel that yes, this issue concerns me, and I can help with this. You guys are subject matter experts. Like I said, there's just 6 of us in Delhi, and we're not experts in the regular sense of the word. We can't make standards on our own. We need your help. You can read the documents prepared. You can comment on them. So with that, I'd like to thank you all. And I would give the stage to our speakers who actually know what they're talking about when it comes to urban flooding. So once again, I thank you all for coming. Thank you.
Thank you, sir. Thank you.
Thank you, Vaibhav sir, for your wonderful presentation. Now the session is open for Q&A. Any questions from the participants offline and online can ask. Any online questions from online participants?
I'm Dr. Vijay Kumar from National Institute of Hydrology.
Okay, sir. Yes, sir.
Thank you, Yadav, for considering the need for establishing standards for the urban management of urban flood.
Yes, sir.
And you have covered it. And I'm happy that you have constituted a committee.
Yes, sir.
Actually, all the existing standards like river conservation and all, they can
Yes, sir.
also, if properly implemented, can have a control over the urban flood. So we have to first review the river conservation doesn't mean only the major rivers. It can be nowadays the urban areas are increasing. Almost 50% of the population live in urban areas. So most of the earlier, you can say, panchayats are now declared as municipalities.
Yes,
So
sir.
it is happening throughout the country. So what we have to see that all the natural riverine zones are conserved properly, and these should be part of the urban planning. And the urban planners and the local engineering teams should work together. And I hope the effort you are making is going to be success in soon. And I wish that you invite all the studies or PhD theses that are available in this to keep in your portal, and so that it is useful for all the committee members, future committee members.
Yes, sir.
Thank you. Thank you very much.
Yes. Once again, like sir very rightly said, that there is a need for implementation of standards. Implementation requires collective effort. Like I said, BIS cannot enforce its voluntary standards on a whim. There needs to be a demand or an order from state authorities, from central authorities, which would require that our standards, BIS standards, be mandated. What we can do is produce the best standards for them to implement. That's our imperative, that our standards are as good as they can be. Implementation is a collective effort with regards to certification, with regards to water resources standards, urban planning, etc. Any other questions? Yes, ma'am. Yes, ma'am. Okay. You can, you just have to, you're audible to me, but I don't think, yes, ma'am. Yes, ma'am.
Yeah.
Yeah.
Thank you. Thank you for the nice presentation. I'm Priyanka. I'm an associate professor currently working at the Center for Environment and Development, ATRI.
Yes.
We are a private research institution.
Yes.
So I'm also currently looking at deployment of nature-based solutions for addressing urban flooding issues.
Yes, ma'am.
So when we say nature-based solution, we are talking about retention ponds, biosales, and you might have come across spawn cities concept in China, how they are putting these systems.
Yes, ma'am.
So when you are talking about, when you say that one of the way forward is to come up with the standards for retention ponds and all, what exactly you are looking for? Like, if you could just throw some light on that.
Sorry, could you repeat that?
So when in the last slide, you mentioned about way forward and standardization of retention ponds.
Yes, ma'am.
So if you could throw some light on what exactly you are looking for.
Whenever there's a standard, let's say there's a code of practice standard. So if, like you said, retention ponds, we can't just have a haphazard approach to building something. A retention pond needs to be.
I would like
Yes, sir.
to
Okay.
answer this. Say, retention pond standardization depends on the dynamics of the urban watershed. Okay. In this platform, we are only exploring the possibilities to identify the areas for standardization in urban flooding. Okay. 2010 guidelines of the NDMA, it just casually gave that, you take care of the urban lakes as retention ponds, but there are no standardizations there.
So we will discuss this later. Thank you so much.
I have 3 points to make.
Okay, sir.
The first one is whatever standards are made. See, earlier model was they were available on sale as booklets actually, and people had to, order from Delhi. Some particular outlet was available, and all these standards were available only from one place. But now with the technology, they can be made freely available for PDF. Please don't consider that the income model because it doesn't work out. Unless people know widely, they will not even ask for it. They will not be aware that there is a standard existing of this nature.
Yes,
For
sir.
example, if I ask 10,500 for drinking water, if people are not even aware what they will demand, they can't, raise that, the demand from their local bodies and local government and state government. So that is one.
Sir, if you just let me reply to that. Just one moment. I'm happy to tell you that all the standards are freely available. Every BIS standard is freely available. You can download it from our portal. My colleague Ajay can even demonstrate our portal to you.
Sir, Nagesh sir, good morning.
Good morning, Ji.
Good morning. I am Bhanu Prakash here.
Yes, sir.
All the standards are available online, sir, and it is free of cost. You have to register yourself on the website. There is a portal available, sales portal, and after registering that, you can download the standards at your end only. So this is
Okay, but there are certain other parts may not be really BIS. Like for example, there is a highway capacity manual. For example, it's an invaluable document, Indo HCM 2018, which is sold for 3,000 rupees. Now for the life of me, I can't imagine why it is treated as a sellable item. Similarly, there is the National Building Code, again, based on which lives are, can be saved. But all these documents are not freely available. It's not the question of BIS alone.
Sir, we are talking about the Indian standards as of now. And if you really want other standards, you please write to us. You are our one of the member and you are aware of it. You will definitely get it through BIS. You see, there are copyright things are there. We will not be able to get some of the standards directly from other standards also. Thank you, sir.
Then second point was access to draft commenting. That even I was not aware that these standards have so many stages and public is allowed to come in and comment on that and probably give more inputs to enrich the standard. So that should be probably touched up through on-site activity. And third point was that presentations and videos which support or explain each standard should be made available from your website only. So, that can be consumed by, users themselves.
Okay.
For the benefit of all, 30 seconds I will take. Amrita Varshini, brought out in both Kannada and English by Karnataka State Council for Science and Technology, is one such document I can refer, which is highly relevant to urban flooding. It tells not only the guidelines for residential planning the rainwater harvesting, it also gets into the recharge levels. It's a very simple and straightforward. And also the manual on rainwater harvesting by CPHEEO. People are already practicing it. It's not that you have to reinvent the wheel. But Vaidya is right, because this platform should be used by convergence of all of us with all these data. That's what is required. Thank you very much.
Okay, sir.
These resources are available in separate places. There should be, a consolidated knowledge base where everything can, is, placed topic-wise.
Okay, sir. Good. We'll now continue with the program, and I'll give the stage to the speakers. Thank you.
That was a very interactive session, but now we'll be breaking for high tea. Tea has been arranged outside the room, so please refresh yourself and we'll be here gathering back here in 10 minutes. Thank you.
Can anybody hear me?
Yes.
Hello. Yeah. Yes, sir. I am sharing my screen. Hello.
Yeah, sir. You can share your screen, sir.
Yeah, 1 minute. Sir, is it visible? Sir?
It is visual. Please also check the. Yeah, sir. It is the slides are also changing, sir.
It's changing? Hello.
Yes, sir.
Yes, sir.
Yes. And my audio is clear? Audio clear?
Yes, sir. Your audio is clear.
Yes, Dr. Sanjay, it's
Okay.
clear.
Fine, sir. Tell me when I have to start. Okay.
Yes, sir.
I keep this as it is.
Yes, sir.
ಮೆಕ್ಯಾನಿಕಲ್ ಶಿವರುದ್ರಯ್ಯ
ಓ ಶಿವರುದ್ರಯ್ಯ
ಮತ್ತೆ ಇನ್ನೊಬ್ರು ಕೆಂಪ ಯಾರು ಅದು ಟೋಟಲ್ 9 ಜನ ಆಗಿದ್ದಾರೆ.
Then if urban or rural planning, can be found out. When you get an opportunity.
Dr. Sanjay.
They cannot learn from the organization, they come again.
Hello. Hello.
Yes, sir.
Yeah. Are we ready to start?
No, sir. They will, TV session is going on. They will take from there. Then we will start this.
Okay. Okay.
విజయ్ కుమార్ గారు.
నమస్తే.
నమస్తే. హలో సంజయ్
బాగున్నారు
గారు.
సార్?
బాగున్నానండి. హలో ప్రొఫెసర్ సంజయ్ జయకుమార్ హియర్.
Namaskar, sir. Namaskar.
Namaskar.
How are you?
I'm good. I'm at IIT Dharwad now.
Yes, yes, sir. I wished you congratulations on your FD page also.
Yeah.
That's great news.
Yeah. Jyoti Prakash, namaskar.
Hello, sir. Good morning.
Namaskar, sir.
Congratulations,
Namaskar.
sir.
Good morning.
Namaste, Yadav ji.
Namaskar, sir.
Congratulations, sir. Jay Kumar, sir.
Thank
IT
you,
Dharwad.
Prakash.
Namaskar.
So now you are in Dharwad or?
I'm in Dharwad, yes.
Oh, okay. So how is Professor Desai?
Desai is good. He is right now auto station.
Oh, okay.
Yeah.
Nice to see you, sir.
Yeah, it was unexpected development, short it happened so fast.
Okay.
Yeah.
So, IT Dharwad civil is there, no, sir?
Civil, yeah, present batch is second year they have reached.
Second year they have reached.
Yeah.
So I was wondering because this Professor Yadav presentation was there for a very long time. I was checking whether my computer has something wrong in sound or.
Yeah, I also had the same doubt. They said 10 minutes and it's
Yeah,
almost
yeah,
40 minutes.
After hearing your voice, then I.
Yeah, it's high T. It's becoming very high.
Oh, high T. They have one. Okay. Okay, sir. I will
Nice,
be
Jyoti Prakash.
sorry,
Thank you, sir.
Professor Yadav. We have our departmental
Thank you,
evaluation
sir.
is going on, so I am just quitting.
No problem, sir. Thank you. Thank you.
Okay.
Thank you.
Sir, see you, sir.
See you,
See
Jyoti
you.
Prakash.
Bye.
Yes, sir. Thanks.
Sanjay Kumar ji.
Yes, sir.
See, they are now trying for the river basin management projects.
Oh,
Only
that's great.
IITs and few NITs are involved. Now
Yes,
you
yes,
write
sir.
to the National River Conservation Director that to involve SVNIT.
Yes, sir. Yes, sir. Yes,
For
sir.
Narmada,
Who is
they put
the-
IIT Indore and IIT Gandhinagar.
Okay,
So
okay.
they are also looking for other NITs. Like Warangal is involved in Krishna. When I was there, it came.
Right, sir.
Now you also write to National River Conservation Director to include your SVNIT in the
Sure, sir. Sure,
Narmada
sir.
studies.
Sure, sir. Sure, sir. Sir, you send the details.
I'll send an email ID.
Director. Yeah, email ID. Right.
So all that you write is you are in the Narmada basin. You would like
Right,
to get involved and you got expertise in this water resource management.
True, sir. True, sir.
See, they have done
I
this
get
National Mission for Clean Ganga. It was successful.
Yeah.
Now they are spreading to all the rivers in the country. So
True, true,
Narmada
sir.
is going to IIT Indore and IIT Gandhinagar. Godavari to IIT Hyderabad. Krishna to IIT Kanpur. IIT Warangal. Now after I joined here, I think we will also get involved. I just wrote to them yesterday.
Okay, sir.
Yeah,
Sir,
so
sir.
you should get involved. We can all meet somewhere, all of us experts.
Sure, sir. Sure, sir. And in civil engineering department of IIT Dharwad, if they are taking, then we can take it in collaboration also.
Yeah, we'll
SVNIT
plan.
and IIT
Yeah,
Dharwad.
we'll plan it.
Yeah.
Actually, our civil is
Yeah.
only 2 years old. The
Right,
second
right.
is there. Yeah.
If any water resources faculty is there, we can plan together.
I'm the only one now. I'm the director, Dr. Desai.
Okay.
A brief introduction on Dr. Sanjay Kumar M. Yadav is a professor, Department of Civil Engineering, SV, National Institute of Technology, Surat, Gujarat. He has over 30 years experience in civil engineering and his area of expertise includes hydraulic engineering, fluid mechanics, water resource system, free surface flow, hydropower engineering, advanced hydrology, professional practice, estimation, specification, and valuation. Sir, you can proceed with your presentation. Thank you.
Sir, am I audible? Hello.
Yes, sir, you're audible.
Yes, Dr. Sanjay, you're audible.
Yeah.
Sir, you are
So,
audible.
good afternoon, everyone. I'm presenting on integrating 1D and 2D hydrodynamic models for semi-arid river basin flood simulation. Yeah, so one can cite this presentation. Basically, this is a seminar on urban flooding, and the presentation which I'm right now giving is on case study, and this case study aims to operation of reservoirs upstream of urban city under extreme rainfall condition. This is one of the issue globally faced by urban cities, wherever there are upstream reservoirs and during extreme rainfall conditions, the releases to save the dam, the huge releases are made from the dams, and what happens to the downstream side of the dam, that is a matter of worry. So in July 2017, India witnessed a series of flooding to excessive rainfall in the monsoon season. States like Assam, Gujarat, Rajasthan, Odisha, Madhya Pradesh, Tripura, West Bengal were flooded in many parts, which lead to loss of life for hundreds of human and several animals, also caused excessive damage to the infrastructure. The region which were semi-arid, they were also prone to flooding, like northern part of Gujarat, Aravalli, Banaskantha, Gandhinagar, Mehsana, Patna, and Patan and Sabarkantha. They were affected by severe flooding in July 2017, heavy rainfall. The basin, the Banas River basin, you will see on the left hand side picture, this is the entire Banas River basin, and in Banas River basin, two dams are situated. These two dams are, one, this is the CP River tributary, Sipu Dam. Another one, this is the Banas River tributary, this Banas River, this is another dam, that is Dantewada Dam. So one is Sipu Dam, another one is Dantewada Dam. Both confluence at 13 kilometers from Sipu Dam as well as from the Dantewada Dam. And from here, the Banas River further flows and it confluences or it meets with the Arabian Sea. You will see on the right hand side the picture of Banas Basin, where you can see there is a Mount Abu, the hilly region, and there were number of towns. If you will see that this is a Dantewada Dam, this somewhere here is the Sipu Dam, and this is the Disa town. This is again a populated area which is just on the confluence of the Banas downstream of Sipu Dam and downstream of that of the Dantewada Dam. Now, what exactly happened? So you can see this is the line diagram of Banas River. You will find that the number of dams are there, as well as the number of tributaries. 7 number of tributaries are joining Banas River. This one is the Dantewada Dam. Dantewada Dam, downstream of it, 13 kilometers. You can see here. This is the Sipu Dam. So releases from Sipu Dam, and releases from Dati Dam, that confluence at 30 kilometers from downstream of Dantewada Dam and that of the Sipu Dam. And from here, it flows down to Little Run of Kutch. The hydrogeological aspects, what happened in case of July 2017? So there was a 14 low pressure depressions formed in the month of July 2017. If you will see, according to IMD report, the number of depressions which were formed, that has been listed in this table. In July 2017, part of Gujarat and Rajasthan have received heavy rainfall because of these formation of depressions. Low pressure regions develop frequently over the Bay of Bengal and move west or northwest, drawing rain into the northern region of the country. But in 2017, the pattern has been strange and unpredictable, with 2 separate depressions present at the Arabian Sea and Bay of Bengal. This picture will make you clear that what has happened in July 2017 over the North Gujarat. This is the one depression which has been moving from the west. This is another depression which is moving from the north, and both combined and resulted into the heavy rainfall in Gujarat from 24th to 25th, 26th of the July. The Mount Abu, Disa, Banaskantha and Dantewada region of the catchment received rainfall of 1,473 mm, 269 mm, 150 mm and 490 mm respectively within 48 hours. That is 23/7/17 to 24/7/17, while the annual rainfall of a basin is 921. The point to be observed is the annual average rainfall of a basin is 921 mm, while the rainfall received in 48 hours is 1,473 mm. which was the maximum of the past 112 years. What further aggravated the scenario is the merge of these two active cycle systems lasted for more days than usually seen in other cases of flooding, such as in Assam 2017 and Chennai 2016, and resulted in heavy rainfall again from 25th till 27 in Banaskantha, Sabarkantha, Patan, and Gandhinagar districts. The recorded rainfall at various IMD rain gauge stations in Gujarat is shown in this next table with normal rainfall and that of the highest record rainfall. It has been observed in the study area Banaskantha, Patan, Gandhinagar, Morbi, Surendranagar, Mehsana, and Sabarkantha 267%, 208%, 189%, 175%, 172%, 130%, and 115% more rain has been received than that of the normal rain within these 3 days, that is 24th, 25th, and 26th of the July. The town, we are talking about the urban flooding, and the town which is most affected by this releases from both the dam is the Disha. And Disa, the normal rainfall of Disa is 226.7 mm, while that of rainfall is 950.3 mm. Point to be noted here is two things. Number one, two dams upstream of the Disa, which were completely filled and there were heavy releases from the dam. And second, the Disa itself received 950 mm of rainfall only in 1 month and specifically in 4 days. So you will see the geography of the region, map of the region. You will see that this is all hilly areas, and here is the Sipu Dam, here is the Dantewada Dam. The runoff which resulted from the heavy rainfall rushed into the Sipu Dam as well as that of the Dantewada Dam, and because of that, what has happened that both the dams get filled fast. You will see the geometry of the river downstream of the Dantewada Dam and downstream of that of the Sipu Dam. Point here is, if you look at the picture which is on the left hand side of this slide, that is near Disa Bridge. This is a Disa Bridge, and you will see the river width. You can see it is approximately half a kilometer, but when you look at the banks, either bank of the river and that of the bed of the river, this is a very shallow river. You can see here the another picture in which also you can see that the depth of the river is very less, because this is a semi-arid river and the carrying capacity of this river is very, very less. So what is the key observation? Shallow depth and low carrying capacity of the river downstream of the confluence of both the releases from both the dam, that is Sipu Dam and Dantewada Dam. So you can see here the picture of the electric pole and its depth, and you can compare it from the bank on the either side, which visualize about the depth of the river, which ultimately aim to explain where the carrying capacity of river is very low. What was the situation of these two dams, Sipu Dam and Dantewada Dam, where this rainfall was happening over the basin? Both the dams got filled up to full reservoir level very rapidly. The dams were already picked up to rule level. As you know that the CWC has fixed rule level for almost all major dams of our country, that they can be filled up to this level, right, to prevent sudden flooding on the downstream side of the reservoirs. And both the dams, as it was a month of July, and according to the rule level which is given to both the dams were filled up to rule level, and this heavy runoff resulted into the full reservoir level. You can see here again the Banas River Basin. These are the two dams, this Sipu Dam and Dantewada Dam, and they conclude 13 kilometers downstream of that of the Sipu Dam. One more point over here to be noted is there is a Narmada main canal. This is the contour canal, partially below ground and partially above ground. That is partially in cutting and partially in filling. And that was at a 63 kilometers from the confluence of Dantewada Dam and Sipu Dam. that was crossing. And here is the canal siphon provided, which is of width of 700 meter. Why I am explaining the Narmada main canal, I will explain you later what happened because of it. So coming back to the reservoir conditions. This is Dantewada Dam. You can see the blue line. And in blue line on 23, just see here, it is almost flat. And from 23rd onwards, the water started inflowing into the reservoir, which was somewhere reduced on 24th. But on 24th midnight, approximately, the inflow shooted from that up to 25,000 cusac to 2,50,000 cusac, more than 2,50,000 cusac. This green line is apparent. That is full reservoir rule level. That green line is the rule level. And you can see that the dam level that is shown over here. So almost the inflow was touching the rule level. Not only that, it is very close to that of the apparent level. Hence, the dam authority has no option. Then you can see here this color orange line outflow, wherein suddenly, see the time period, that is 24th midnight or so to that of the 25th day of 25th. You will see within 24 hours, the releases from dam has reached to 2,25,000 or so. And it continued, not only reached, but it continued for a considerable hours. So you can imagine what would have happened to the downstream side of the dam. This was the condition of first dam, the Dantewada Dam. Similarly, when you will see the outflow was 2,10,000 cusac from the Dantewada Dam, and if you will see the other dam, that is Sipu Dam. For Sipu Dam also during the same date, that is 24th and 25th, you will see that the blue line, which is an inflow, and that inflow was suddenly rise to that of 3,50,000 approximately, right? That was on the 24th evening. Even it has crossed the rule level, it has crossed the dam level. That much high inflow was there, and that has resulted into releases of water. You can see continuous releases of water up to an extent of 2,50,000 from Sipu Dam. So what if these releases are there from two dams? What would happen on the downstream side? So Dantewada Dam 2,10,000 cusac, Sipu Dam 2,50,000 cusac, total 4,60,000 cusac that has come at this point on the midnight of 25/7/2017. I have shown you the image of river. River is having shallow width, and because of its shallow width, what will happen? The water will spread over a large area on either side of the bank. Apart from that, there is a contour canal, that is Narmada main canal, which was partially in cutting and partially in filling. So the flow which has released from both the dam rushed towards the Narmada main canal or on the downstream side, and this Narmada main canal has, as it is partly above the ground and partly below the ground, that has obstructed the flow. So what happened due to huge releases? You can see these are the pictures, flood inundation due to Banas flood, right, over the entire region, which is on the downstream side of the dam. You can see the damaged roads, the damaged the villages which are submerged. This is the Umbri village, downstream side of the dam. This is Abhiana village, which is also flooded completely in 2017 floods. This is the Narmada main canal. So as I said that it's a control canal and partly above and partly below the ground. The water which has released accumulated in front of the canal, and later on it breached the main canal not less than 20 sections of the main canal, and major repairing is required to be carried out after this particular flood. In this analysis, we have done 1D hydrodynamic model to find out the water level on the downstream side of the dam at various locations, which identified the villages at the high risk. And in 2D hydrodynamic model, we have worked out the depth of inundation in areas as well as the spread of the flood due to these releases from the dam. The data, as you know, that for any modeling, we need lot of data to be collected. The data were collected, flood hydrograph of Datiwada Dam from Datiwada Dam Authority, flow hydrograph of Sipu Dam from the Sipu Dam Authority, stage and flow hydrograph at Kamalpur Central Water Commission, stage and flow hydrograph at Umri Gauging Station, River Gauging Station Office, Palanpur, flow hydrograph of Narmada Main Canal, that is SSNL Gandhinagar, actual flood injection dam. The actual questionnaire survey has been conducted to find it out the dam. These are the steps, model development steps of 1D using that of the Mike Hydro model. This is the river cross sections which we have collected and plotted completely into the Mike Hydro river model, and at various chainages, which are the locations, like I have shown the photograph of Umri village, that is at this particular chainage. This is the Kharia village. This is again a significance why I have marked it on this particular slide, that I will show you at the next slides, and the various chainages across which the water level and water depth that were studied, and extent of water surfaces and water depth has been observed. This is a cross section of one specific river, how the modeling is done, and this gives you the boundary condition for boundary conditions, inflow hydrographs, that is outflow hydrographs from Datiwada Dam, outflow hydrographs from Sipu Dam, and the water level at the Kamalpur gauging stations. So that has been given in the as a boundary conditions. And to validate the model, you need the calibration data as well as that of the validation data. And for that, the questionnaire survey has been carried out. This is my research scholar, Nikunj Mangukia, who has visited this flood affected area and collected the survey data of inundation of the downstream side areas of the dam. The 1D hydrodynamic model has been set up in Mike Hydro, and the simulation period 24th July to 26th July, total for 49 hours, that has been considered, and for the maximum releases, the model has been run. These are the outputs of what we can say water level, time series water level at various locations, A, B, C, D, water level, time series, discharge time series, water depth size series, and water flood depth time series has been. This is again a view water level profile for Banas River. Maximum water level at particular section that has been identified because of release of the heavy releases of the water. These are the parameters which were considered for calibration and validation of the model. And finally, the observed water level and simulated water level has been compared for the Umri gauging station for 2017 flood. What is the outcome of this? Similarly, for Umri also, the observed and simulated water levels were computed, right? So, what is the use of this? Doing this, we have identified the cross-section changes, right bank, left bank, and water level. And we have also find it out what will be the water level above the bank at that specific change, and you will find that at the cross section of 82,619, the level of water above the bank is 4.362 meter, while here it is 6 meter. Means the villages which are around this particular chainage may have got the depth of water in terms of 4 to 6 meters, right? So as we have seen that there is a less difference between the salvage line, that is the depth of the river, and the adjoining areas. You can see that the water level is up to the extent of the 6 meter has been observed at this particular chainage. Similarly, we have identified 4491, that is 5.07 and 4.2, 19760, 4.901 and 6.37, and 126.169, 4.765 and 6.362. When I'm saying chainage, this chainage has been incorporated with the village. You can see if I talk of 82619 chainage, the villages around it are Akol, if I 685573, the villages around are Ranpur, and this is the Disa town. You can see here the population also in the Google map, which was first affected. And in Disa town, I talked to the commissioner of the Disa, municipal commissioner of that Disa, that time who was in charge of this Disa town, he said that the water was up to 2-storied building near the bank of the rivers, and they have rescued so many people from the Disa during these floods. So these changes which we have shown, that what depth it have, that has been marked on the Google map to identify which are the nearby villages have faced what depth of the water. So this again, the Kharia story of Kharia will come after the 2D model. This is a Kharia village, and this blue line you see, that is Narmada main canal. And at this junction, there is a canal cipher. And as I said, the Narmada main canal is partly above and partly below that of the ground. So this is the critical flood reaches of Banas River identified from 1D model, which will be having depth of water right from 1.67 meter to that of the 5 meters. And these are the villages which are affected, identified from the 1D model, which were affected by the flood or water surface. So these are cross sections wise, the list of the villages has been made. And after that, we have gone for the 2D hydrodynamic modeling. In 2D hydrodynamic modeling, this is also been done in Mike 2.1. And in Mike 2.1, you will see that this is the study region considered, and 3 scenarios were considered. Number 1, without Narmada main canal. Number 2, with Narmada main canal. And 3rd, bridge Narmada main canal. Some participants' microphone is on. Please mute it. So there are 3 scenarios. Please pay attention now. This is the river Banas, right? Which carries the water after the releases from Dantewada Dam and Sipu Dam, and it is flowing downstream. As I said, it meets the Arabian Sea, Little Kachop Run, and later on Arabian Sea. And this is the Narmada main canal. The line which you will see here, that is the red line with the Narmada main canal. So what has happened? The water which is released from this dam as this canal siphon, which was having only 700 meter of width, become an obstruction for the safe draining of water. And therefore, what has happened, that water is accumulated this side and this side, both the side of the canal. And here is the Kharia village somewhere. Yeah, this is the Kharia village. You can see this is the Kharia village. And in Kharia village, the depth of water before the Narmada main canal bridge was of an extent of 6 meters. And 18 family members of one family died in this incident at the Kharia, which is one of the saddest part of this entire tragedy. Of course, there are 200 human beings lost their life during this flood, because as I said that this river is having very shallow depth. The villages are, the people are staying on either bank of the river. You will find that there were a lot of village people. They were living on the bank of the river, because this is a semi-arid region. They have never thought that this much of water the river will carry. And all this happened midnight of 25th/7, 12 o'clock. When my research scholar Nikunj interacted with the people of this particular region, they said that they were sleeping. And suddenly they saw that in their house, the depth of water is 30 centimeters. They woke up and stand. And by the time they stand on the floor, the height of the water was around chest height. That is approximately 1.6 to 1.5 to 1.4 meter. And they were not realized that from where this much of water is flowing into that particular region. So you can imagine what would have happened to the people of these villages, which were at the midnight, didn't know from where this much of water is coming, and the depth is increasing suddenly. So 2D modeling has been carried out. 3 scenarios has been taken up: without Narmada canal, with Narmada canal, and bridge Narmada canal. Please pay attention to my next slide. There are 3 pictures in this. That is A is without Narmada main canal. Means suppose we consider that there is no Narmada main canal, and the flood water which was released from 2 dams have to pass from this area. Then what would have happened near the siphon? Because this is in partially cutting and partially filling. So it will be forming an obstruction to natural draining of the water. So this is scenario number 1, in which we have considered that there is no Narmada main canal, and the how water would have receded. In B, you find with Narmada main canal. Suppose Narmada canal is there, and then how the water will be accumulated, or how the water have passed through this particular section. And third, the breached Narmada canal. When the water has overtoppled the Narmada canal, as I said that though it is a lining partially below, partially above the ground, made up of earthen material, it has been breached. And when it has breached, what will be the condition? So we start the 2D models at 24/7/2017 at 12 o'clock midnight, and we progress it slowly for 24/7/17 16 hours. You can see here, this is Narmada main canal without Narmada main canal, that is A. B with Narmada main canal, you can see the spread is less here, the spread is more, accumulation is more here. You just see these colors, you see yellow color or red color, that indicates the higher depth, which is missing in case of what we can say Narmada, modeling without that of the Narmada main canal. And when it is breached, this is the accumulation, and this canal is about to breach. What is the depth of water? You can see on the upstream side of the main canal. This is 24/7/17 14 hours. Then 24/7/17 at 8 o'clock in night, 8 o'clock. So you can see the spread of water without main canal, that is number A. B with main canal, Narmada main canal, and number C when the Narmada main canal is breached, right? You can see again 25/7 midnight. This is again A, B, and C, how the water has moved, and this is again 25/7 morning 4 a.m. and you will find that this Narmada main canal breached in the morning. By that time, you can see Runi, Kharia, all these villages have depth. Red color you can see, that is the depth about 3 meters. And that incident which took place in Kharia village, where 18 family members died of same family, that is located over here. This Runi was also having water depth more than 6 meters. This Kharia was also having water depth 6 meters. And you can see that the Narmada main canal breached and the water started flowing on 25/7. So it started accumulating from 24th. It breached on 25/7. Till that, the depth of the water on the upstream side of this Narmada main canal, right, that has reached to alarming level. You can see this red dot on either side of the canal, that is left bank of the Banas river and that of the right bank of the Banas river. Later on, this is 8 o'clock. This is a completely a devastation on upstream and downstream side, and the water has flown, right? This is 25/7 again 12 o'clock, and this is again 4 o'clock. You will see that how the water has progressed again, moved over the entire region. So we model it up to 26/7 at 12 o'clock, right? 26/7 4 o'clock. So again, I would like to show you all the slides with one click. That please pay attention that how the water or release water, the flood waters have moved over the entire region with main canal, without main canal, and with bridge canal. So let us start on 24/7 at 12 o'clock.
Minutes more, kindly.
Yes, sir. Yes. Just I am about to complete. So this is the section A, this B, right? How the water is moving, right? And it will be completely there. So finally, the depth is simulated depth at various villages that has been identified village wise, and from the cautionary survey, the modeled depth and that of the simulated depth that has been compared. These are the villages which are affected because of Narmada main canal. The hydrographs were drawn of actual flood depth and the simulated depth for number of villages. This is the list of the villages. What was the depth of water at the various villages that has been marked. The role of Narmada main canal and the role of canal siphon that has been assessed. it has been said that the canal siphon, instead of 700 meter, it would have been 1.2 kilometer. Probably the damages which has happened, that may be less than the what happened in case of July 2017 floods. So this is again all the actual comparison between the simulated depth and the actual depth. And finally, this is the map which we have prepared for flood inundation, right, on either side of the bank of the river, including all the villages which are on the left bank as well as that of the right bank. The details of this, anyone is interested, this is our paper which is published, and if anybody wish, I can share this paper with them also. Thank you very much. Thank you, sir.
Thank you, SM Madhav, sir. That was a very wonderful session. The session is open for question and answers. Any participants having questions can speak.
Was there a scenario with Narmada channel not carrying any water from Narmada?
No. Sir, carrying of water from Narmada was not an issue. The issue was that the canal was partially above the ground and partially below the ground. So because of that, what has happened, it has created a kind of barrier which has not allowed water to drain fast. Of course, there was a 700-meter canal siphon, but that 700-meter canal siphon, it would have been 1.2 kilometer or 1.4 kilometer. Probably the flood water might have receded faster.
But the role of Narmada water also adding to the local water would be there, right?
But sir, releases are so high, it is an extent of 5 lakh cusac, and probably the Narmada main canal may have 30-35,000 cusac. I don't think so it will be more than that. So of course that will affect it, but till the canal is not breached, because after breaching, the Narmada canal also added into the released water. So that has made devastations on the downstream side of the Narmada main canal.
Sir, I have one observation and it's a question.
Yes, sir.
Recently in Libya, because of the
Right, sir.
cyclone and storm, a dam was washed away. So
Yes, sir.
my question is it possible to simulate using these models the situation
Yes, sir.
which the dam gets washed away?
Yes, sir, it is possible.
Okay, thank you very much.
Yes.
I have a question.
Yes, ma'am. Please ask.
Yes.
So this is a wonderful study, sir. Thank you so much for sharing that with us. So my question is like now, because this study was done post the flooding event, now how the learnings are being shared with the government, with the practitioners, with the policymakers, so that these kind of events doesn't happen? Or are there any early warning systems which are being in place so that public is being told beforehand, so that the damage is reduced? So are there have you taken these studies to the policymakers and to the practitioners?
Ma'am, this question has a very long answer, but briefly I tell you that the Indian hydrology, Indian flood forecasting system, Indian warning system has improved a lot. They need compliments for it. If you have witnessed the coastal floodings in South, there are incidences where not a single death was observed after successive storms of last 3 successive storms. So in total, the flood warning systems all over the country, they are improved. Number 2, there are agencies, even the authorities and administration, they have also become aware, and at number of events, specifically what happens that due to early warning, the people are saved or people are migrated from one place to that of the safe locations. So definitely, madam, that India is progressing fast in that way, but the extreme events are such that we need a certain more concrete steps to prevent what we can say losses during such happenings.
Sir, good afternoon. Very excellent presentation, sir. I have only one basic question. You had shown that the base of the river has very shallow depth. and which is almost
Yes, yes, sir.
merging with your banks. Is it the natural
That's
level, sir? That's my question.
Yes, yes, sir. Yes, sir. Yes, sir. Actually, it's a semi-arid region, and this region before 2000, year 2000, receiving very less rainfall. Due to climate change, what has happened that extreme flood events have increased in this area after 2000, while the rivers remain the shallow, which is the problem all over the globe. That because of climate change, the certain regions are receiving very heavy rainfall, and because of that, the flooding has happened on the downstream side.
Thank you, sir. Thank you.
Sir, I am Dr. Vijay Kumar.
Yes,
from
sir.
National Institute of Hydrology.
Yes, sir.
Actually, the effect of the dam on the proper transport of sediment downstream helps in rise of the riverbed. So this has also
Yes,
to
sir.
be focused, this aspect. There should be proper flushing of the dams regularly, and the channel downstream has to be maintained, and such precautions have to be taken. That is what part of the river conservation I am telling. River conservation
Yes,
means
sir.
taking care of the river, its cross sections
True, sir. True, sir.
and everything.
Sir,
So,
sir,
and
sir.
also
But
this
sir,
is a disaster actually. This is a disaster,
yes, sir.
and
Right, sir.
this is a flash flood, you can say.
Right, sir.
So, and also the canal has got an underpass. Its design capacity must have been designed very less. So such things have also to be considered to see that in future we take proper measures.
Sir, there are two things in what you have said. Number one, the sediments. So when the releases are in terms of floods, so flood water carries the sediments. So it's not an issue during flood. The deposition will happen. Sediment deposition will happen when there is a receding floods. And that rightly said, during the receding floods, if the sediments are not washed away, the channel bed level may rise. That is one thing. Second thing, about the carrying capacity of the siphon, which is designed over the Narmada main canal. Sir, the precedent of rainfall, that is 112 years, the river basin received the rainfall 1 in 112 years frequency. So probably the designers have a limitation to decide about the width of the canal siphon. And the climate is changing up to such an extent that it has become very frequent and common that whatever may be the 100-year return period rainfall is there, or whatever may be the 100-year return period runoff is that has been crossed, or that the rainfall is even more than that. Hence, not only the canal, but all over the world, they are redesigning the dams also. And if required, they are providing auxiliary spillways, looking to the intensity of the rainfall which is received by the basin, that will ultimately flow into the reservoir, and the reservoir spillway is designed for some capacity which has exceeded because of the extreme rainfall due to climate change. And hence, over the world, there are dams in which, apart from that of the regular spillway, they have added auxiliary spillways into the reservoirs. So similar type of a thing is required to think about the Narmada main canal also.
Sir, I have a question with you. Sir,
Yes, sir.
The thing that whatever you have done is a post-disaster event. But
Right, sir.
is it possible to learn something that regarding the operation of the reservoirs? Because see, for example, when the two peaks meet at the junction, probably it would be having the maximum disaster. But if they delay the releases, probably the peak of the first dam meets with the lowest point of the second dam, probably the volume of water would be less. So is there any the rule curves or the operation manuals which we can develop out of your study, which would help the reservoir operators for reducing the impact of this flooding?
Yes, sir. Yes, sir. I'll show you the hydrograph, what you have pointed out. Just give me a 1 minute. Actually, sir, the inflow, what is happening in the climate change scenarios, which is very challenging, is this, sir. Sir, if you see this, right, the inflow, if you see the inflow line, that is a blue line, the rainfall in the river basin only in few hours, it's in terms of 100 mm, and that makes the runoff. You see this line, blue line here, and within a only few hours, the inflow into the reservoir reached from 25,000 to 2,75,000. So under such circumstances, it's very, very difficult to release the water gradually. There is no option for the dam authority to save the dam than to release the water. So how to check this? That is a big issue all over the globe. Not only for our country, but this is also a global problem. What somebody has talked about the Libya also happened the same thing. The very intense rainfall in short duration, maybe 4 hours or 3 hours, which results into high inflows into the reservoir. And that time, the authority is left with the saving of the dam. Otherwise, if the dam breach happened, it will result into the loss of life of thousands of people instead of few hundreds, which is happening now by regulating the dams.
Sir, Yadav sir, but Dr. A.K. Singh is waiting, sir.
Yes, sir. Yes, sir.
I have one small quick observation. November last year, sir, for your question, and also for the speaker. November at KRS, Karnataka, Kishla Sagar, BIS conducted dam safety virtual seminar, sir. There, Madhavan gave us an account of what is happening in Karnataka with regard to the spillways design for the unexpected upsurge of the deluge. You see, I think there is a best practice in Karnataka within the 2 WRD divisions. If an integration is there, sir may get an answer. Thank you very much.
Yes, sir, that is correct. That is right.
Sir, it was a very nice deliberation by you, sir. It's most interesting, I can say. We require at least 4 hours deliberation on this. And
sir, true, sir.
Right now, Dr. A.K. Singh Sahab is waiting. And
okay, sir. Okay.
Invite him.
So I stop my presentation.
Yes,
okay.
Thank you, sir. Now I would like to call Dr. A.K. Singh. He'll be presenting on lesson learned from Patna floods and way forward. A brief introduction. Dr. A.K. Singh, with his master's and PhD in disaster management and an outstanding meritorious academic record, has more than 15 years of research, training, and capacity building experience on various aspects of disaster management with several reputed national and international centers of excellence, level of governance and policy making to the grassroots levels. His interdisciplinary academic background, varied professional experience across sectors levels with dozens of independent peer-reviewed publications, lectures, and invited talks at reputed national and international forum bear a testimony to his academic and professional experience. Now the stage is yours, sir. Thank you.
Thank you, BIS, especially for touching our lives, touching lives of every Indian in a positive manner and impacting us. You have a great task in hand. Let me start with that. Since you've taken up this issue, and it is a very, very complex issue with so many stakeholders and so many aspects of urban flooding, so many types of urban flooding that I'll explain in a while. But there have been talks about this dams and about infrastructure. So I would like to start by reminding you that we are in Amrit Kal, 75 years of our independence. So all our critical public infrastructure, including dams, reservoirs, embankments, roads, drains, drainage systems, buildings, have almost reached their half-lives or have either completed their half-lives. So there is a major issue in hand with respect to decommissioning, retrofitting, revival of dams, embankments, buildings, critical public infrastructure, So you need standards for all these issues with respect to that. And then there was a question on whether there are groups and all. Government of India has come up with NDMF and SDMF, State and National Disaster Mitigation Funds, where up to 5% of the expenditure can be made on such studies. It is to promote and engage various stakeholders, including various academic institutions. There are networks like IUIN networks of Government of India, IDRN networks. There are several sectoral thematic networks, regional, spatial levels they are working, where there is convergence of these people. Yeah. So I come from a very different perspective. There's a lot of technical things here. I will talk about the human perspective and from the administration and management perspective, from the lives, from the point of view of a disaster manager, where everything fails. Why everything fails? It is a horror story from Bihar that is happening city out of city after city. So I'll be talking more on the human perspective and how things actually work and translate at the ground level. Before that, I would like to present a work so that you are aware of the entire world of urban flooding and some of the work that we have done. Can you go to the chapter 3? We are talking about technological solutions. So chapter 3. So there are a range of actors, and what we have done is we have come up with the standard operating procedures, departmental checklists, and action plans for each and every department. There are about 16 emergency support functions which need to work, and they are in just the post-disaster phase. Chapter 3. So the work is available, standard operating procedures are available, they are being updated. Their guidelines are available for urban flooding. The departmental checklists are available. So these all things are available because if you go through this, there are about 13 departments, 14 departments for which we have prepared. This is the, can you just stop at one or two places? Maintenance of, yeah. This is the list of entire work that has to be done. And if you see inundation mapping, it's just the tip of the iceberg. Whereas it is the most important part through which we come to know the hazard risk vulnerability analysis, through which we know which areas will be flooded and when they will be flooded in what kind of scenario. Scenario building, simulation modeling, and this inundation mapping, other kind of mapping like digital elevation modeling and others, they are just the beginning of the journey. It is just like the human body. You see so many organs function, and until unless all these departments perform all these functions in a coordinated manner, brain dead is a person dead. So coordination is the brain. You need a person to coordinate. And the problem is with urban flooding is that it is no one's baby. I'll come to it. So then there's another important aspect. Someone said it is related to rainfall. There are several types of urban flooding. We've seen urban flooding due to Kosi. We've seen urban flooding in Sikkim and due to dam breaks. We've seen urban flooding due to heavy rainfall. So there are several types of urban flooding. Why it is important? 2/3 of India lives in our villages. But now what is the scenario? By 2050, 2/3 of India would be living in her cities. Then urbanization leads to these kind of catchments where flood peaks go up by 8 times compared to normal floods. And within a matter of minutes, things change. So then there is an element of climate change which is further complicating the issue. The number of cyclones of category 4, category 5, they are increasing. There is the urban dome effect. So the past 3 decades, disasters have quadrupled, increased by 4 times. in this region, and economic losses have gone up by 6 times. With climate change and the things that have been incorporated in IPCC 6 and others, the worst is still to come. And I could see it in Bangalore as well, where along the roads with respect to urban flooding, there are no drains. The road itself is the drain throughout the route where I came. So another important aspect is that who's going to deliver this urban flooding? We are going to come up with functions. We are coming up with several roles and responsibilities. Who's going to deliver this? Mr. Yadav is there managing the seminar. He'll be doing wonderful work. But at the time of COVID, at the time of this thing, he won't be able to reach his office. He won't be able to reach his people. He won't be able to communicate with his people. So it is a nightmare, beginning of a nightmare. In India and across the globe, more than 92 to 95% institutions, public and private, have no business continuity planning. Whenever a disaster strikes, there is no business continuity planning. I think BIS also would not have any planning in case of a major disaster, how it is going to function and effect. And this, we know. So the staff that is going to work, we have to look into issues. We are delegating responsibilities to staff. Where does urban planning happen? Urban flooding happen? Which are the most vulnerable areas? Which are the most marginalized people and marginalized areas? Where are they staying? And these are the places where our drivers are staying, where our pump operators are staying, where our common people, our students, our other people are staying. So these issues have to be looked into from the human perspective. And despite this fact, I would like to highlight.
वो AK सिंह बोल रहा है, वो नहीं था? इसको हटा देती हूँ फिर, लीव कर देती हूँ, छोड़ो. ये कोई
Disaster risk reduction. Today is the World Disaster Risk Reduction Day as well. So there is a convergence between BIS and DRR here. UNISDR has declared this day as DRR Day. So we congratulate you on both the accounts. So we have come up with a Disaster Management Act, and they say a paradigm shift from response phase to the disaster risk reduction phase. We know that it is established that $1 in disaster risk reduction or mitigation or resilience saves $10. But yet the global situation is that DRR funding constitutes only 0.03% of the total developmental funding available globally. 0.03%. So that is the status. Can you come with my presentation? So I need not go into the technical details. You all are already technical people. You know that things are getting worse. Rainfall, there are concentrated periods of rainfall. There's earlier it used to be staggered through a longer phase. Now there's heavy rainfall within 1 or 2 days, and especially during hours. And I would like to correlate urban flooding with kind of its management as well as the problem with traffic jam. What is happening with traffic jam, and what have we done to ourselves? Traffic jam during peak hours at 5 p.m. and at 9:30 p.m. At 9:30 a.m. I was coming. All the cars, all the vehicles are on roads. Everything is on the roads. This is exactly what happens in urban flooding. And it is not just this catchment, it is the entire catchment area of a river, entire catchment area of the city. Water has a very unique property. It goes to the lowest point, it gets accumulated there. Rural flooding, urban flooding are very different, because rural flooding, water has an outlet. You have an option where to pump water. It can be shifted. But here in this thing, it is just like Bangalore city. You pour a bucket of water there, you pour a bucket of water there, you pour a bucket of water there. Everything comes down here. Whether it is coastal flooding, there is high tide, what has happened in Mumbai, what is happening in Chennai and other places. Whether it is Patna, Ganga, Punpun are already above danger mark. You are at the lowest level. Where do you pump the water? What do you do? So this is where urban flooding is very unique. Water comes in from all over the region. In Patna, water came in from Jharkhand, from UP, from MP, and it accumulated. And where do you pump the water? Suddenly, certain areas are 6 feet under the water within a time frame of minutes. And these areas are the areas where we found out we had all the contingency plans, we have all the people, we have pump operators. But they were living in these areas. Ambulance drivers are living in these areas. Their families are what is neglected on our part where the planning lacks. The human face, what I'm talking about. Their families are also at risk. So you want to come to work, you want to contribute, you are not able to contribute. So this is where urban flooding is unique, and it is very important because urban areas are the actual growth centers that contribute to the GDP of a country. You bring down a city for a halt for 5 days, there's a loss of thousands of crores in cities like Mumbai, Chennai, Bangalore, other places. So that is the importance of urban flooding. You can come down. Acha, I will have to come down. So this is also one of the aspects which is technical. You know, there is urban heat island, why there is sudden rainfall. So is this one important? Yeah, this is what is happening. This is what Mumbai was. And you can see the red area now. This is what we have converted into Mumbai. So all the natural channels, all the sinks, all the areas where water could be absorbed is now going into the sea or into the areas. Earlier, this is the hydrological cycle. Urban flooding has to be understood by the hydrological cycle as well. 5% of the water used to reach the rivers and our drains. 95% down. Now with urbanization, this is what urban flooding is all about. And this is what management has to be all about. 95% goes into the rivers. And it is not 95% of the city itself. It is from as far as like for Patna, MP, Nepal, Jharkhand, and other places. All the river is coming, all the water is coming to the lowest point. Okay. One important thing about urban flood is very low risk perception. Whichever disasters have costed us a lot, from tsunami to others, have very low risk perception. Risk perception at all levels. Like for stakeholders, individual level, if I say, I block my own drain. I build a kind of a ramp for putting up my car. I'm an important person. I build a ramp and I block the drain. So it is just like the human circulation, drainage network of the city. What happens when one artery or one vein of your body is blocked? You get a heart attack. So simply they are all interconnected. One person blocks it. He says that it won't affect. It is just a small drain in front of my house. Now that leads to 5,000 houses and 5,000 blockages. This is what happened in Patna. This is what happens in every city. And you get a heart attack. In fact, we get a heart attack when we go to manage it. So this is the level of risk perception that you have in everything. You go on an encroachment. I am a person looking into the development authority. I say that, oh, the river can flow, water can flow. We have encroached upon rivers. They used to be 4 or 5 kilometers span. Now we have constructed it. Water can flow. But you are not prepared. You are not looking into the worst case scenario. 1 in a 100-year event. And that is now coming. Our data suggests that every individual on this earth faces 1.6 serious disasters. 1.6 times serious disasters in their lifetime. We are in a place where 95% of disasters of the world are concentrated. So be assured that every person in this room and their family are going to face 5 to 6 such situations in their lifetimes. So this is the magnitude of the problem that you have to understand. But people don't understand. 50% of the drains, what is happening? Urban flood. Cities used to have a carrying capacity. Cities were planned, its systems were planned for a particular set of people, a few lakh people. That has increased by 4, 5, 6, in several cases, 10 times and 100 times. Now, what is happening to the water and the systems? What is happening? They are functioning, there is siltation, every muck, poor solid waste management, everything goes into the river, goes into the drain. We found out that in Patna, they used to clean the drain. And when they clean the drain, in order to get it measured and all that, they used to keep it on the side of the drain. Now, as soon as it rained, all the muck went back into the drains. The drains that were already functioning at 50% capacities went even further. So the carrying capacity of the city and the population is increased. The city is not able, the systems are not able to cope up. And whatever systems are existing, Amrit Kal, 75 years, 50 years, they are functioning at 50% of the efficiency. So you need to get standards for this operation, maintenance, management, cleaning. In fact, our principal secretary, we had come up, it was so embarrassing that we had to, I guess it is getting recorded. Okay, we had to evacuate our deputy chief minister. It was in news, so I can mention it here. And a very embarrassing situation. So the highest level of committee, 5 principal secretaries of government of Bihar, spent months into coming up with the report. And what did they come out? With these very simple basic problems through which the flood peak could have been managed. Now, if the flood peak of Patna could have been managed by 20%, the actual suffering of the people would have been lesser by more than 50%. We just needed to manage this peak. So, talk about cities. What happened in Patna? On September 27, 2019, IMD had predicted a rainfall of 21 mm over 72 hours in 14 districts. What actually happened and this happens with standards. We come up with good standards, we come up with good complicated studies. But who are going to implement it? Who are going to study it? Who are going to calculate all these things? Because you need to be prepared for the worst case scenario. Government of Bihar, the clerks and other people saw that 21 mm of rain. We had done our inundation modeling. We had gone to the extent of determining what level of rainfall, 65 mm, is the thing when Patna would get flooded to the extent it got in 2019. It is only 21 mm. What happened actually? It was 177 mm of rainfall within 48 hours. So early warning forecasting. And even if it had not rained, 177 mm, 21 mm, we need to understand 21 mm across 14 districts. And in the entire region means something else for Patna city, which is, and its low-lying areas, for any city. I've given this example, drop 5 buckets of water there, everything is coming here. So this is what happened. So it was unprecedented floods. And in a matter of minutes, Ganga already, the worst case was 52 meters in 1975, it was level. On 28th, it was 50.68, 29th, it was 50.67, 30th September, it was 50.79. Similar was the case of Punpun, where it was almost flowing at the highest level. And what is most interesting to note is the last bottom line that they found. Urban flooding is an important issue, and this is how the English child is. No new major drainage network developed since 1968. The last major drain was built up in 1968. So that is why I'm bringing this Amrit Kal into play. The status of the drains, the status of the thing, unlike in Bangalore, it is the same story everywhere, in every city. There are no drains. And what people have done, they did the intelligent job. For normal scenario, 21 centimeter of rain that was predicted, it actually rained much more. They had joined the sewer lines. So now the sewer lines were the storm drainage networks, an important learning for us. And when this happened, everything was flushed into each and every house of the area. Because the sewer system, everything got devastated. So high-level committee was constituted. It came up with a range of issues. One was this accountability, transparency, the way we manage our drains, the way we clean our drains, the efficiency at which the already existing systems are working. This is at least what we could have managed. And by managing just this, with 100% systems working, the drainage network working and cleaned, we would have reduced the peak by more than 20% and sufferings by more than 50%. It would not have been the embarrassment that is what it was for the government of Bihar on a global scale. So what had happened? Every year, the contract went to the same contractor. I'm not going to the nitty-gritties. You can understand how things were working. The contractor used to clean the drains, not to 100%, some cleaning on the side of the drain. It rained, it went back. Now there were serious issues of procurement, emergency procurement. We complain very often that systems do not work, people do not work, files do not move. There's a classic case of Bihar. A district magistrate Patna appeared on the front page of Time magazine. It is this disaster management work that he ultimately died in jail. He died out of cancer, not due to jail, but he was jailed due to these issues. So it is emergency procurement. What was happening? First, we did not procure enough because preparation was for 21 mm of rain. We did not procure those many pumps where it could be pumped. We did not have a HRVC plans in place, hazard risk vulnerability plans. We did not know what areas will be flooded and to what extent despite the inundation maps and all. So it was a serious channel. Then these pumps were working on electricity. Only 30% of the pump were working on diesel. When we started, it was to work for 3 days. After 24 hours, diesel was a challenge. When there was such an unprecedented flood, power supply was a challenge. When you go out for these pumps, another important challenge was procurement. The rate of service contract was not there. The district magistrate and authorities were not ready and willing to go. Then there is a great department called audit department. Or in all the previous cases, what happens in disaster management, whoever serves us never ever comes back to us. Until unless it is the other way around of these contractors and all, where 50% of the work is done and 100% claimed. What was happening? There were so many audit objections, there were so many pending dues of these contractors that no one was ready and willing to help. So these advanced rate contracts, everything was not there. Then there was no planning, inundation map was not there. Where do you pump the water? Even if you want to pump, what is the length of the pipe in the system that you need? This all needs to be calculated. There needs to be standards for all this. You are pumping a water, you cannot pump into any other colony. Then there are 17 services that are to be delivered. Emergency support functions, right from safety, security, law and order. People had to be evacuated from the top of the houses. They could not take their belongings, they could not take their things. So the law and order, other issues are a serious problem. Communications, completely down. Food, civil supplies, completely down. Transport, very difficult to reach these areas. Trained person, capacitated person, not available. HR is not available. You have the pump, you don't have the pump operator. He's living in the area where he and his entire family is threatened. You have the ambulance, you don't have the driver. Because he is himself become a victim. You expect me to work for 72 hours. But what about my family? I'm staying in that place. Where is the focus of all the relief, all the work, all the developmental work? It is in the posh localities, main localities. The focus is the chief secretary, the focus is the other departments. There's another serious issue that came up.
Singh Saab, could you conclude in 5 minutes?
Yes, I will, sir.
Subrao ji is waiting.
Yes. That irrigation, while flooding has a dedicated lead, urban flooding has none. When it comes to funds and all that, everything it is our responsibility. When it comes to actual delivery, the ball is thrown from one court to the other court for every service, every action that is required. Municipal corporation to development authorities, to the urban development, Nagar Vikas Vibhag, to the Awas Vikas,